Good evening, I'm Mike Knetter, and welcome to the UW Now Livestream series, where we bring you experts from the UW community talking about timely and important topics. Tonight's subject is climate risk. We will discuss the scientific evidence on the human impact on climate, the consequences of climate risk for the Earth and its inhabitants, how these risks manifest in industries like insurance, in pricing and products, and some observations on how society can manage these risks in the years ahead. We're joined by four experts. Steve Ackerman is the Vice Chancellor for Research and Graduate Education and a professor in the Department of Atmospheric and Oceanic Sciences. John Nelson is an adjunct professor of Civil and Environmental Engineering and Chief Technology Officer of Fitzgerald Asset Management. Jonathan Patz is professor and John P. Holton Chair of Health and the Environment and Director of the Global Health Institute. And Ben Wright is Senior Vice President and Chief Underwriting Officer at Homesite Insurance, an American family insurance enterprise. Thank you all for being with us this evening, taking time out of your Tuesday evening. Our audience truly appreciates that. And I look forward to some great presentations and lively Q&A I'm sure to follow. Leading us off tonight is Steve Ackerman, Vice Chancellor for Research and Graduate Education and Professor of Atmospheric and Oceanic Sciences. In Madison, of course, he's also known as half of the duo we refer to as the Weather Guys. He is widely published on weather-related phenomena, especially on understanding how changes in the Earth radiation balance are affected by changes in other climate variables. His numerous awards include the NASA Exceptional Public Service Medal and the American Meteorological Society's Teaching Excellence Award. He's a fellow of both the American Meteorological Society and the Wisconsin Academy of Science, Arts, and Letters. Steve earned his master's and PhD in atmospheric science from Colorado State University. Steve, thanks for joining us tonight. I started my day in a meeting with you, and it's great to wrap it up with you again.
Thanks, Mike. I really enjoy being here. I really enjoy this UW Now program and very happy to be here talking about climate change and its risk. And what I would like to do in my few minutes here is just to lay the groundwork of the basics about climate change. And the fundamental basics from my point of view is that whether an object warms or cools is related to its energy gains and losses. If it gains more energy than it loses, then it's going to warm up. And those gains and losses are relative to its environment. So for Earth, our environment is space. So our energy gains from space are driven by our energy gains from the sun. And the energy losses we have is that any object that has a temperature emits radiation, and in this case, we call it terrestrial radiation or long-wave radiation. And so the fundamental look at how the Earth's surface temperature, what it is, what its distribution is primarily determined by this balance between the absorption and emission of radiation. And if we look at it as a planet, what we see, and we can measure this from space because we have satellites. Wisconsin is the mecca of satellite meteorology. What we find is that the tropical regions are gaining more energy than they're emitting to space. And the polar regions are emitting more energy to space than they're gaining from the sun, which is not surprising because in the wintertime, they're in darkness. So the response to that is that the atmosphere and the oceans establish circulation patterns that are always trying to move energy out of the tropics into the polar regions. Now, what's happening with climate change recently is that our human activities are changing the composition of the atmosphere, and that's changing and modifying how we absorb and emit radiation. These gases, which are known as greenhouse gases, in particular are carbon dioxide and methane. These gases do not absorb solar radiation. So when we put them into the atmosphere, that solar energy still finds its way right down to the surface, doesn't have an impact on the energy balance of the planet, of the atmosphere. Surface heats up, emits terrestrial radiation. Carbon dioxide, methane absorb in that terrestrial radiation, and that causes a warming of the planet, of the atmosphere, and then the planet. So that's the fundamental basics as I see what happens about climate change. It's driven by energy gains, energy losses, and those imbalances. Now, even with that simple conceptual framework, we can start predicting what we might expect to see in a changing climate where the atmosphere is warming because we're adding these greenhouse gases. And so if you go to the next slide, here are some of the 10 things that we could relatively argue we would expect to see. One is on the right-hand side there, the temperature of the atmosphere is going up because we're increasing the amount of these greenhouse gases. As the atmosphere warms up, it's going to emit terrestrial radiation back down to the surface. It's going to be in contact with the surface, and that's going to tend to warm the surface. So might expect that snow cover, ice cover is going to decrease because of the warmer atmospheric temperatures. And we're seeing that. We're seeing Arctic sea ice decrease. We're seeing the number of glaciers decrease. And we're seeing also the amount of snowfall decreasing. Because the atmosphere is warming, its interactions with the ocean, we might also expect that the sea surface temperature would go up. Ocean temperatures would go up. And indeed, we're seeing that as well. And as you warm water, you're going to expect it to expand. As you melt glaciers and they find that water finds its way into the oceans, we might expect to see global sea level rises. And indeed, we're seeing that as well. And then finally, one thing that it's hard to argue in terms of the energy imbalance, but as the atmosphere warms up, we're going to see more water molecules in the atmosphere. So we would see an increase in the amount of humidity in the atmosphere. So those are 10 things that we would expect to see just to argue on the basic physics of a warming atmosphere. And all of these things are actually observable in today's world. Now, I'm not going to go through all 10 of these, but I want to give a couple of examples and then talk about how that impacts our lives. So the first one I want to show is our record of lake ice on Lake Mendota, and that's in the next slide. This is a long-term record going back to the 1800s. And so on the x-axis is the year, and on the y-axis is the duration of ice on Lake Mendota. Black line is the for a particular year. There's always a lot of annual year-to-year variations. And so we often will run a 5-year filter on that to smooth the data a little bit so that visually we can see what that impact is. Statistically, it doesn't have an impact if we were to run it on the black data. But if you look at the red line, you can see that there's a general decrease in the amount of time there is ice on Lake Mendota. And indeed, if you look at the last 20 years, so going back to about 2000, that thin straight line is the median over this 100 and something year period. And all of the last 20, except for 1 year, the duration of ice on Lake Mendota is less than that median value over the entire record. And if you go back to the beginning of that record, the first 20 years, you can see almost all of those years, they're above what that median value is averaged over the entire record of time. And if you look at those values, you can see that we're talking about between the last 20 years and the first 20 years, roughly 20 to 30 less days in which there is ice on Lake Mendota. So that's certainly reflective of a warming climate. And it also now impacts how we live, right? A big thing in the Wisconsin culture is ice fishing. Many families do that. And if the amount of ice is changing on the lake, then it's going to reduce the amount of time that we can participate in that activity of ice fishing. If we go to the next slide, we can also look at some other aspects that we've looked at with regard to winter and springtime. One thing that we've looked at is the Wiki initiative analyzed surface temperatures during springtime and also looked at the springtime minimum temperature and how that's changed in the last 57 years or so. The springtime minimum temperature is going to be often reflected of what the nighttime low temperature is on average. And those red areas, you can see the springtime minimum temperature over the last 57 years or so has increased by about 1 degree. And the dark regions are almost 2 degrees. So what we're seeing, and we can do the same thing during the daytime for the springtime maximum temperature. And when we do that, what we see is that the nighttime low temperatures are warming faster than what the daytime highs are. We're also seeing that the greatest amount of warming is occurring in the wintertime and in the springtime. There are a number of ways to look at how the winter times are changing. That's one way. Another way we can look at it is how many times a year or days in a year is the minimum temperature less than 0 degrees Fahrenheit, so sub-zero temperatures. What we see now in comparison to over the 50-year record is that that is occurring less frequently on the range of 6 to 24 days, fewer days in which the temperature is getting below 0 degrees Fahrenheit. So fundamentally what we're seeing is we're still having wintertime. It's not as cold. Now, if you don't like cold winters, you may view that as a good thing. But if you like ice fishing, if you like snowing, those warmer temperatures are going to all influence how we do our wintertime activities. In addition, wintertime activities are really big for the Wisconsin economy. The other thing we can look at is how many days a year, or in the springtime, when do we have our first temperature or our last temperature less than 32 degrees Fahrenheit? And then in the fall, when do we have our first temperature less than 32 degrees Fahrenheit? And that time difference essentially defines the growing season for that year. And when we average that over the 50-year period, what we find in terms of trends is that the growing season is lengthening anywhere from 1 to 4 weeks since the 1950s. And again, that'll depend on where you live in Wisconsin. Now, if you're a gardener, you may think, well, that's a great thing. But with that warming temperature and increased growing season comes invasive species as well. They can survive the harsher winters that we used to have 50 years ago. Those temperatures also infect cultural activities that we have. A big one in Wisconsin, as well as economy, not just culture, is maple syrup harvesting. Maple syrup harvesting, that's a good time when you have warm, sunny daytimes, and nighttimes you want cooler temperatures. And if our nighttime temperatures are increasing, that's going to impact the duration of the maple syrup harvesting time period. And in fact, predictions are looking out, by the time we get out to 2050, this is not going to be an optimum environment for maple trees to grow. They're going to be different trees that are going to want to be living in our climate. So I want to summarize it in the next slide by just saying, the physics in this climate change is very well known. We've known what the physics is for a long time. We observed this global warming. Experts agree that it's humans caused. I very much simplified things. These interactions are complex. But the interactions and the expectations are observable and they're consistent with one another. And then finally, I just want to mention that the way we have lived in terms of increasing carbon dioxide emissions into the atmosphere has changed our climate. And what we're seeing now is that changing climate is impacting how we live, not just in terms of energy consumption, but in what we do, how we enjoy outdoor activities. So thanks, and I look forward to potential questions.
Great. Thank you, Steve. Great presentation. And next up, we have Jonathan Patz, Professor and John P. Holton Chair of Health and the Environment and Director of the Global Health Institute. Jonathan has appointments in the Nelson Institute for Environmental Studies and Population Health Sciences. He co-chaired the Health Report for the first congressionally mandated U.S. National Assessment on Climate Change. And for 15 years, he has served as a lead author for the United Nations Intergovernmental Panel on Climate Change, an organization whose members shared the 2007 Nobel Peace Prize. His numerous awards include being an Aldo Leopold Fellow, a Fulbright Scholar, and winning the Cianciolani Global Health Research Award. He's an elected member of the National Academy of Medicine, and Jonathan received his medical degree from Case Western University and his Master's of Public Health from Johns Hopkins University. Professor Patz, great to have you with us tonight. The floor is yours. Tell us about the human impacts.
Thank you, Mike. Thanks so much. It's a pleasure to be here. I'm going to be talking about the health risks from climate change and the health opportunities from climate action. Now, really what you think about, the typical image that you think about when we think about climate change is this polar bear stranded on an iceberg. But when you think about the issues, there we go, make sure I got my advance here. When you think about what Steve just presented, the physical attributes of climate change, higher temperatures, sea level rise, extremes of the water cycle, what I'm concerned about is how these affect our health. And because of these multiple pathways, be it heat waves, air pollution, infectious diseases, water and food supplies, mental health and environment, refugees, and to the right, you can see the health impacts, the health outcomes. You know, this is why I've dedicated my career to this problem. I view this challenge of climate change as the greatest public health threat of our lifetimes. So instead of the polar bear, these are the faces of climate change, really. It's a human health concern. Working with the Nelson Institute Center for Climatic Research, we've looked at extremes in temperature. Notice that right now, a place like New York City, which has about 13 days on average in a summertime that are hotter than 90 degrees, that number will triple by the middle of the century. And Dan Beaumont, who led this work, found this true for about every city east of the Mississippi. Those were the cities that he studied. And in Texas, it's about a doubling of cities with 100 degrees. So it's a problem. And if you extend these extreme temperatures around the world, looking at the top map is mid-century, the bottom map is the end of the century. Everything in red has a 90% probability or greater of having a record hot temperature in the summertime. That's a big concern considering the climatic envelope that crops grow in. You know, it can be if it's too cold or if it's too hot, crops can't grow. And according to Roz Naylor, an expert crop modeler at Stanford, today's 840 million people at risk could double just in a few decades. That's a public health disaster. Now, of course, there are some plants that will benefit from more CO2 and more temperature, higher temperature in the atmosphere. Northern Hemisphere, we have 27% more CO2. Wisconsin has warmed 1 degree Fahrenheit, as Steve has mentioned. Our number of days for allergies for ragweed has increased by 13 days. So this is a major concern for anyone that has asthma. So the bottom line for plants is that food crops are not going to do so well. Ragweed and poison ivy will just do fine, and that's a problem. Now remember, it's not just temperature rise. As Steve pointed out, it's extremes of the water cycle. Looking at these projections from the Wisconsin Initiative on Climate Change Impacts, WICI, that Wisconsin really is primed for flooding, and we already experience much more rainfall. You can see on the left column there all the different health impacts from more flooding. We conducted a study in Chicago and its watershed and found that because of the extreme intensity of rainfall and runoff, that Chicago will see a doubling in the number of their combined sewage overflow events, which overflows into lakes and streams. this happens, and we're really concerned about this as a water contamination issue and for our health. And floods do pose risk to water contamination. But after extreme floods, what do we actually see in the emergency room? We see people coming in with asthma. So to the extent that we are going to be seeing more higher repeat frequency of 50-year flood will become the 5-year flood, and people's basements being flooded, this is a very serious health concern. Now, some people argue that the greatest threat from climate change will be the smallest, and they're talking about these mosquitoes, these insects that are cold-blooded. So unlike us, we're warm-blooded, our body temperature is about the same all the time. Insects are extremely sensitive to subtle changes in temperature. So if that mosquito is carrying dangerous viruses, in fact, the Aedes aegypti mosquito does carry yellow fever, dengue, and Zika virus, the development rate of those pathogens inside the mosquito is completely dependent on the air temperature, because that's the same as the body temperature of that insect. So infectious diseases carried by insects are really sensitive. Now, that's the bad news. You know, there are so many climate sensitive diseases, and it's very concerning. But when I think about what do we do to combat climate change, I think it could be free or even a net benefit. So I've been writing about, challenges and opportunities. Solving the global climate crisis could be the greatest opportunity of our time. A low carbon future could improve global health and achieve economic benefits. If you think about the sectors, the sources of greenhouse gas emissions, the three sectors that I put that dotted line, the three sectors to the right, electricity generation, food, and transportation, that's about 2/3 of greenhouse gas emissions. And I just want to focus on these sectors and show you some amazing opportunities. In the energy sector, air pollution from burning fossil fuels kills 8.7 million people every year. So 8.7 million premature deaths every year. Dave and Sarah Epstein have been, they're fantastic alumni donors that are actually helping to fund research at this intersection of energy and health. Another big sector, the food sector. A very recent pivotal report, the Lancet Commission in 2019, recommends this universal healthy reference diet. And it's a diet that all of you know, which is very low in red meat, higher in fruits, vegetables, nuts. You know the diet, right? But we have so much extra red meat and I have to say some dairy as well, and other highly environmentally impacting diets. If we got to a universal healthy reference diet, that would save 11 million premature deaths every year. And in a conversation with Carl Frick just yesterday, he introduced me to a group that's working on sustainable fish protein, which is very exciting, could solve the malnutrition problem and the energy impacts from the food sector. So that's very exciting. And the third sector is transportation sector. Unfortunately, a majority of Americans don't even meet the minimum recommended level of exercise. And 3.9 million people die every year prematurely because of sedentary lifestyles. So we have a project, the Health-Oriented Transportation Project, looking at this. John Holton has been helping in this sector. In fact, I'm John Holton granted me a chair, so he actually is a big donor behind all of this research, to be honest with you. So I will just say, just to the unbelievable benefit that these three sectors alone, you know, getting to a low carbon society across those three sectors could save half of all deaths that occur every year. So 24 million deaths avoided. It's amazing opportunity. I think it's the greatest opportunity of our times. And I'll wrap up by just saying we've done a state analysis. This is work by David Abel and Katja Speer from our university. David was a graduate student in the Nelson Institute for Environmental Studies. Katja Speer is in CALS. This is the energy scenario. It's a clean energy scenario for Wisconsin. What does that mean for health? It means 1,900 fewer deaths and all of those other listed benefits. And if you add up these benefits, we're talking about a savings of $21 billion every year in air pollution related savings from especially fine particles and ozone pollution, from reduced mortality, hospitalization. It's incredible. That's every year. And also in this report, of course, green jobs netting 162,000. So I'll end by saying that, why don't we treat climate change like we're treating the COVID pandemic, like we're treating infectious diseases? Because after all, climate change is a global health crisis. Thank you very much.
Jonathan, thank you. We look forward to questions and answers with you soon. Jonathan and Steve have talked a bit about some of the implications of changing climate, droughts, floods, fires, storms, all these things. And our next guest can talk a bit about what we know about property destruction and insurance claims stemming from those catastrophes. Ben Wright is Senior Vice President and Chief Underwriting Officer at Homesite Insurance, an American family enterprise. In this role, he now leads product development, management, data science, and operations teams for the homeowners business. Wright has been with American Family for almost 20 years in roles spanning actuarial, finance, product management, and product development functions. Prior to his assignment at Homesite, he was Vice President of Personal Lines Product Management at American Family. Ben graduated from UW-Madison in 2002 with a BBA in actuarial science. Ben, thanks for joining us and giving us this important industry perspective on how you're experiencing climate risk.
Thanks so much for that warm introduction, Mike, and thanks for inviting me to this live stream. What I want to cover over the next few minutes is how the property and casualty insurance industry, which exists to help restore customers' lives after experiencing a loss, views and has been impacted by natural catastrophes and weather-related events. Moving to the first slide, the number of recorded loss events or events that caused economic loss resulting from natural catastrophes such as storms, floods, droughts, and wildfires has been steadily increasing for some years now, with more rapid increases observed in the past decade. We've seen the number of catastrophe-related loss events more than double over the past 15 years, now with over 800 events globally per year over the past few years. We focus just on 2020 in the United States. Natural catastrophes were the highlight of the year for the property insurance industry. The Atlantic hurricane season was the most active and the fifth costliest on record, with 30 named storms, 13 of which that developed into hurricanes, including 6 major hurricanes with top wind speeds of 111 miles per hour or greater. Additionally, wildfires were very prominent throughout the second half of 2020. Throughout the year, approximately 58,000 wildfires burned over 10 million acres, the most acreage impacted in a single year on record. While much of this burn occurred in unpopulated national forest system land areas, more and more people are being impacted by wildfires as they move towards some of these areas, particularly in states like California. Additionally, both within the insurance industry and outside of it, we still don't have a good understanding of how these fires really work, and that presents even greater risk. Finally, here within the Midwest, we were struck by a derecho this past August, which impacted areas like Iowa and Minnesota in particular. This derecho generated wind speeds of up to 140 miles an hour and was the costliest single severe storm event to strike the United States since 1980, causing an estimated $7.5 billion in damage. And so these loss events are real, and they've been having a big impact on the industry and the customers that we have. Moving to the next slide, in addition to the number of events going up, we're seeing more and more customers are living in catastrophe-prone areas. Today, as an example, close to 40% of the United States population lives in a coastal zip code, even though this area represents less than 10% of the US landmass. Additionally, people are moving to areas that are more susceptible to natural catastrophes. You can see growth rates increasing, such as here, which with areas in the south bordering, hurricane-prone areas, increasing at a much faster rate over the past several years than other areas of the country. And after all, who doesn't want to live in a climate that's sunny and warm year-round, right? In addition to these changes, we're also seeing that a greater portion of the population and businesses are insured. In the early 80s, it was estimated that only around 25% of losses resulting from a natural disaster were actually insured, even in highly developed countries. Today, that estimated rate has nearly doubled. While that's still far from 100% coverage, that change has had a meaningful impact on the insurance industry. And for example, in some states, well over half of customers' home insurance premium can be attributable to expected weather-related events and or natural catastrophes in the area that they live. And so you have this combination of the number of events increasing, coupled with more and more of the population living in the areas where these events are actually occurring. If we move to the next slide, we can see what the combination of these increasing number of events and population shifts has had on the insurance industry when it comes to losses. As shown here, those increases have resulted in material increases to the insured losses over the past 2 decades. Even when adjusted for inflation, aggregate insured losses over the past decade were over twice as high as the decade that preceded it, at over $500 billion over the past 10 years. If we move to the next slide, this changing nature of risk has created new needs for insurance companies and, more importantly, their customers. To start, products and coverages have had to adapt to further meet customer needs. Jonathan spoke about increased flood risk, for example. Flood insurance historically has largely been provided by FEMA with fairly tight restrictions. We're finding, though, that customers are moving to areas that are experiencing flood, but are outside of the traditional flood zones that FEMA have identified. And so the private sector has had to step in and provide new flood products to help fill in those gaps. In addition to new products, insurance companies have had to move towards sharing some of that risk that we've seen with customers through things such as higher deductibles and coverage restrictions in catastrophe-prone areas. In part, this is to help make the cost of insurance remain affordable, as well as to make insurance accessible to people that are in these areas. As customers have moved towards towards areas more prone to hazards, the industry has also had to proactively work to encourage more appropriate risk mitigation practices. Examples include influencing building codes to help structures withstand things such as strong winds and hail, as well as partnering with privatized fire departments to help protect homes within the perimeter of wildfires. Finally, we've had to rethink the way that we price and underwrite risks. Many of you that have owned a home over the past decade have probably seen a meaningful increase in the insurance premiums that you pay. A big part or a big portion of that increase has been related to increases in weather-related events and associated losses. In addition to that, however, the insurance industry has had to re-examine the modeling techniques used to price weather-related and catastrophe perils. Traditionally, insurers have used historical losses associated with a given geography and risk type to predict losses for that same geography and risk type in the future. These techniques use very sophisticated models that leverage advanced modeling techniques such as generalized linear models or machine learning models. However, for certain perils such as wildfire and other catastrophes, we found that these traditional techniques haven't done an effective job of predicting the future as much so as desired. And now some in the industry are looking to marry some of those traditional modeling techniques with more stochastic, physics-based weather and climate prediction models, so that we can better predict average annual losses, associated standard errors, and use those predictions to better price and underwrite risks. Ultimately, climate change is real, and it's had a significant impact on the risks the insurance companies cover. Both insurance companies and their customers have had to adapt to the ever-changing climate over the past several years, and will need to continue to do so in the future. With that, I'm going to turn it back over to Mike.
Ben, thank you for that very practical tour of how you see it from a business perspective. It's a great complement to our academic perspectives tonight. John Nelson is an adjunct professor of civil and environmental engineering in the College of Engineering, and he is also the chief technical officer of Fitzgerald Asset Management, a boutique registered investment advisor that focuses on the development of sustainable infrastructure. John's scholarly interests include the intersection of climate and energy and human transactions with nature via sustainable infrastructure. His research and applications involve the design, building, operation, and financing of sustainable infrastructure. John's a member of the Wisconsin Foundation and Alumni Association Board of Directors and serves as chair of the Alternative Assets Subcommittee. He is a registered professional engineer and received his master's degree in mechanical engineering from the UW Solar Energy Laboratory. John, the floor is yours.
Thanks, Mike. Great to be with you tonight. Thanks for this tremendous opportunity. As Mike said, our business funds sustainable infrastructure because infrastructure is at the intersection of human activity and climate change. It's ground zero for climate risk. I don't really need to spend any time on this headline because my colleagues have already demonstrated that climate risk is obvious and settled. But just from an infrastructure perspective, on the left side, you see the recent storm in Texas, headlines from it, where the electricity grid shut down. We own bonds from an electric utility in Texas, and so that's something we're paying careful attention to. And on the right side is from 2012 when Hurricane Sandy struck New York City. So there are all kinds of headlines like this, and this matter of climate risk and infrastructure is very clear. Next slide, please. So the way we're responding to this reality is a refinement about how we think about infrastructure. And it involves this concept of sustainable infrastructure, which is first, resilient to extreme weather events, second, restorative to protect those risks from worsening over time, and third, decarbonizing to the extent possible to reduce or eliminate carbon footprint. Now, I've been at this for a couple of decades, and a while ago, I found a seminal work depicted here in the middle about how to differentiate between thick and thin sustainability. It was very helpful, and it guided us to focus our work on thick sustainability. Now, the reason we do that is because it matters. It's measurable, it's repeatable, it's at scale, and it's material. Thin, on the other hand, is useful. Sometimes it's about intention. Sometimes it's about a symbolic gesture. Unfortunately, there is a lot of greenwash in this business. Greenwash is advertising intention or action, but not actually doing it. This subject of sustainable infrastructure also has very interesting scales. On the physical environmental side, as these pictures depict, this stuff is huge. It's unimaginable, indescribable, hard to explain. You almost need to see it to understand it. And on the temporal scale, you'll see the word in parentheses urgent. I'm going to come back to that. But infrastructure is deployed over decades or longer, or generations. It's not unusual for us to work on a project, and I'll show one, that's 100 years old. So I'll come back to that. On the human scale, it's really hard to calibrate the two. And I was made imminently aware of this early in my professional career when my wife, Linda, and I toured one of the projects I'd worked on, and she's standing in the middle of this complicated work with all this equipment around and things most people never see, and asked three prescient questions. The first was, "You did this?" The second was, "It really works?" And the third was, why aren't you paid more? I realized at that point in life it would be hard for me for the rest of my life to answer the question at the cocktail party, so what do you do for a living? It's just hard to calibrate. Next slide, please. So I'm going to talk about three themes that my colleagues and I are developing in response to these climate challenges for infrastructure. The first being thick, resilient public infrastructure. The key words here are mitigate and adapt. Now, we finance this with a product called Resilient Muni. It buys conventional municipal bonds. For those of you who haven't been familiarized with municipal bonds, it's the way public entities finance infrastructure. They sell bonds, they pay a coupon on them. At the end, they return the principal, and over time, they collect taxes or fees or revenue of some form in order to meet those financial obligations. And right now, we're evaluating bonds being issued by New York City for their wastewater resiliency plan. It's an exemplar of this matter of resiliency, and pictured is a map out of the plan. The white area are the boroughs of New York City. The green is largely the Atlantic Ocean or the Hudson River. And then the shaded areas, the amber areas, are how, as a result of sea level rise, floods begin to encroach on that landmass. The dots are pieces of infrastructure that need to operate continuously regardless. And you can see this is evidence of the climate risk that Ben talked about. So the cost to harden these pieces of infrastructure against this climate risk are significant, and they're urgent. New York City's been working on this for over 15 years. They have written the book on how to think about this and on what to do about it. Started before Hurricane Sandy, and I'm confident that our company will invest in this next bond issue to support this. Next slide, please. The second theme is thick, restorative public infrastructure. Its keywords are preserve and restore, and it chases its roots all the way back to the book some of you may have read called Natural Capitalism. We finance thick restorative projects through something called Eco-Muni, which is, again, the purchase of conventional municipal bonds. And the South Florida Water Management District, better known as SWIFT-MUD, is an exemplar for this matter of ecological restoration. Anybody who lives in South Florida knows the population is growing exponentially, at least it was until COVID. At the same time, maybe you don't know that the supply of fresh water for human consumption was rapidly depleting. The fresh water in South Florida is provided by two sources. It's provided by aquifers below the surface of the earth, and it's provided by that huge ecosystem embodied by the Everglades. Those systems, in addition to being depleted, were being compromised by encroachment of salt water and brackish water from sea level rise, climate-induced sea level rise, which actually makes the water unfit for human consumption. So SWIFT-MUD has developed a comprehensive plan to deal with this in a manner that restores, not just that protects. So we have invested in bonds that involve habitat restoration for the surface water, that involves reservoir or aquifer recharge for the aquifer water, and a whole variety of other things. So that's this thick restorative theme. The third theme, next slide please, is thick private infrastructure decarbonization. The keywords are mission central and mission critical. I'll come back to that in a minute. But this is about building and operating infrastructure in a manner that materially decarbonizes its footprint quickly. The example is Ford Ford has been a leader in this discussion for a long time. You might remember a book called Cradle to Cradle about how to reinvent industrialization. That was William McDonough, sponsored by William Clay Ford's interests. And this project that's pictured in the lower right, in which this eco-deboom project we've invented was used, is the redevelopment of Ford's Technology Center in Dearborn. This is a place where roughly 30,000 people work, and its refreshment included infrastructure that cuts its carbon footprint by up to as much as half. Now, this eco-deboom system was used because Ford recognizes that infrastructure, while mission critical to them, is not mission centric. Ford is in the mobility and the transportation business. They know they can't optimize infrastructure at the same time, as well as an independent party who's expert at it does. So this structure allowed Ford to develop infrastructure that materially reduced their carbon footprint immediately through efficiency improvement, through the implementation of renewables, and then for baseload, shifting from coal to natural gas. This project went online about a year ago. So it's one of these things that can be done right now at scale and be measurable. Next slide, please. So through these themes, I've tried to demonstrate how climate risk is managed in infrastructure. I bet you can see that there are no silver bullets here. There's just a lot of silver buckshot, and we're working on developing them. The primary themes that I've presented are resiliency through New York City, restoration through Swiftmud, and decarbonization through Ford. I'd like to conclude by mentioning a couple of headwinds we have. The first is incentives. We need better incentives for transparency, for technology development, and for rapid deployment at scale in all three of these domains. For example, renewable energy like solar and wind, it can't be deployed for baseload until we have a robust, massive deployment of storage, of energy storage. Similar for carbon capture and sequestration. So we need the right set of incentives. And the last matter involves urgency. As I've communicated, the rate of increased climate risk does not calibrate with the rate at which infrastructure is changed. For those mathematicians online, this is a second differential problem, a rate of the rate problem. While awareness is profound and planning is really advancing, deployment's not. Deployment's not going fast enough at scale. We have a lot more to do immediately and ultimately. And this is a great opportunity. Mike, back to you. Thanks for letting us participate in this dialogue.
Well, thank you, John. And thanks to all of our guests tonight. Very informative show. We've got a lot of people watching, a lot of questions coming in. I'm going to start with a question from Craig Mansky. Craig notes there's a lot of talk about CO2, but not much talk about urban heat sinks. He notes the huge additions to impervious surfaces, roofs, concrete, asphalt in deserts and mountains. What is the effect of these human impacts other than CO2 on climate? Jonathan, do you want to start?
Yeah, sure. It's something that's very concerning in the health area, because heat waves over an urban city that's sprawling with black asphalt roads and concrete buildings, these heat retaining surfaces, you get what's called the urban heat island effect. It can be 30 to 40 degrees hotter. Steve, correct me if I'm wrong, okay? But in the urban heat island, it can be much hotter, and that's very concerning. It's, as far as its contribution to global warming, Steve can answer that question. But as far as the immediate health risk, you put a heat wave on top of a sprawling city, and the urban heat island effect is very serious.
Steve, thoughts on that?
Yeah, and that's definitely true. I don't know if it's a 30-degree temperature change, but there was studies even going back into the early 1950s looking at the heat island effect of London. So they've been making those measurements for a while. You can see them on satellite imagery. They do pop up. They are serious, not just in terms of temperature and air quality, but also precipitation. So as precipitation increases, particularly heavy precipitation, because as Greg pointed out, the non-porous surface, we get a lot of urban flooding that's also associated with that. So yeah, urban heat islands is definitely another example of human impact on our environment.
Thank you both. Question from Norman Arndt about Greenland, which is right above my head on the map. Norman notes that it was green when the Vikings were on it, and they were driven off by glaciers on the island. He notes maybe we're going back to the way it was 500 plus years ago. Are we coming out of an ice age? So really it's a question about, is it secular or is it man-made? And Steve, you want to start, and then I'll let others chime in?
Yeah, I think, that's a good point. And, we've been focusing on atmospheric effects. But as I mentioned early on, one way that we move energy out of the tropics and into the polar regions is through oceanic circulations. And so one of the reasons people have looked at, oceanographers have looked at, with regard to the ice going away in Greenland back in those Viking days, was there was a change in the ocean circulation. So the Gulf Stream went much further poleward than it is now, and that led to a warming of that area. What we're seeing now is that the Gulf Stream is not going that far. We are seeing the Greenland ice sheet really melting rapidly. There is concern that that will change the ocean patterns, particularly the Gulf Stream directions, because of the fresh water is less dense than salt water, and so it sits on top. And that's going to change potentially what the Gulf Stream pattern is, which may again then rapidly increase and change what we're seeing with regard to polar climate.
I'll just say that I don't think Greenland was ever green. It was Eric the Red who landed on Greenland, and he called it Greenland to get his other comrades to come follow him.
Is that true?
Yes.
Okay. Well, I won't, I think in general, there's some questions out there about causality. I think people maybe can buy into what we see the trends being in the data that we can measure. And I think there's a set of questions often about, are we just measuring more and better and in different places that, might have more hard surfaces, as Craig Mansky noted? And how certain are we about the causality? And that's, I think, a question that lingers for some. As an economist, I always say, I can certainly believe there's been too much pollution because we've underpriced the cost of it forever. And that leads me to conclude we've probably done way too much polluting, and there's consequences to that. But Sue Hilke wonders, what other countries might serve as models for addressing climate change, and how scalable are their efforts to countries the size of the U.S. and the largest industrialized countries? And, I don't know, John, do you have thoughts about that? Or
Right. We try to look globally, even though we only invest in the United States. And if anybody's ever been to the Netherlands and walked around and seen how they've dealt with being an ocean-bound country and stood in a medieval city and looked up and seen a boat go by above your head in one of the channels, you can appreciate the magnificence of their culture and their engineering that's allowed them to persist like this over centuries. So it was, without elaborating too much, it was just interesting to me to see how the Netherlands have responded to sea level rise compared to how we responded to the events that occurred associated with Katrina. I would say in the United States, we tend to use a brute force method And in the Netherlands, they tend to use more of a cooperation method. They sort of have already accepted the fact that they're below sea level and that they need to live with that and find a way to cooperate with it. So there are examples from other places in the world. There are other places deploying renewable technologies, but I'll stop there.
Anyone else want to chime in on that? Other countries as models?
One other thing I'll add in terms of countries working together as a good example is the Montreal Protocol, where we recognize human impact is changing the ozone layer. And therefore, what are we going to do about it? Multiple countries got together, came up with policies and guidelines in order to reduce chlorofluorocarbons and in order to minimize their impact on the ozone concentrations in the stratosphere.
I can speak to below sub-country level. So there's a state compact in New England about cap and trade and carbon emissions. And there's cities around the world. London has a congestion tax. You're not allowed to drive in the city. I think Norway is now banning, they're getting away from gasoline cars in the city. So there are lots of places all over the place at a smaller level besides country. There are plenty of shining lights all over.
Ben, we got an insurance question. Who expected that? How will insurance companies address the population shifts that you talked about in terms of policy and premiums? And, are there situations where you could envision that we won't even insure people that move to particularly high risk areas of some type?
I think a couple things there. Insurance companies always strive to match price with risk. And so, similar to what I mentioned before, I think what you'll see is this continuing effort to better understand the nature of risk and then price for that appropriately. In some instances, though, it is more than just price. And you'll see coverage changes, such as either reducing the coverage or maybe eliminating the coverage for certain perils. You might see higher deductibles, meaning a higher sharing of risk with customers. You could also see, certainly in some insurance companies, them managing exposure. And, at the individual risk level, you can get an understanding of that risk and its average annual loss. But there's also something about, probable maximum loss, so to speak. And as an individual company insures more risks in a very finite area, the more risk effectively that they're taking on incrementally per risk that they add to that pool. And so you may see some insurance companies also scale back eligibility and say, hey, I'm only willing to insure a certain amount of customers or a certain amount of risks in this geography before I have to step back because the capital requirements are just too high. And so I think that's been something that insurance companies have been evolving and instituting over a long period of time. And I think all of those methods you'll see put into place as population shifts further.
Ben, could you just give us a sense of how big the variability is in the premium rate, per dollar, let's say, in some of the higher risk areas of the United States versus a lower risk area? Like, where are the high risk areas, where are the low risk areas, and what are we talking about for magnitudes?
Sure thing. If you go to a state like Florida, for example, which is obviously very susceptible to hurricanes, you may see hurricane premium in general in some of those territories be 85% of the premium or more. And even in the what would be deemed the lower risk areas of Florida, you still might see an average premium for a home there of around $3,000 a year. You look at some states, more in, I guess, between the Midwest and the West Coast, where you don't have a lot of kind of the Midwest convective storms. You also don't necessarily have the wildfires that exist out in the West. There you're going to see an average premium of several $100s. And so you're probably seeing a 5x or more difference between some areas that are not as prone to catastrophes as those that are.
Question from Donald Wen. Where do the energy storage advances fit in the equation of solar and renewable energy opportunities, let's say, going forward? Any thoughts on that, John?
Yeah, that's something I'm looking at right now, because if you looked at Bloomberg today, you see that Elon Musk has deployed some of those giga batteries down to Texas, which was a pretty obvious solution to the sort of event that occurred recently. It's back to what my colleague and good friend Jonathan said. There are lots of these bright shining lights. If there's something I have hopefully communicated, is that we've got to get them at scale. And even as much as we like Tesla as an automotive company, I think they make in a year what some large automakers make in a day. So they're not at scale yet either. And the challenge is that these risks are continuing to advance. So yes, it's hopeful. Yes, we're making good technology progress. We need this to scale.
Thank you, John. And a question from Steve Goldstein. We have 4 experts here that consider climate change as having immediate disastrous impacts. Where is the voice from the other side on this? And, I guess I should first raise my hand and say, I invited these guests. So I had some idea what some of you would say, but I didn't really know exactly what my industry experts would say about the subject. And I will also note for our audience that I take responsibility for not having a more diverse panel. We try to do that, and for a variety of reasons that didn't work out this time. But Jonathan, any thoughts about where's the voice from the other side on this, besides the fact that I didn't get one, apparently?
Right. Well, I'll just say that we're in a different time right now, and even if people didn't believe in the climate science, which of course, what you heard from Steve, there's consensus, and people should recognize the debate is over. But even if you just forget about climate change, we're in a different energy era. I mean, the price of solar energy dropped 99% since the 70s. 2 years ago, the International Renewable Energy Agency, for the first time ever, said that if you remove all subsidies, the cheapest way to generate electricity is renewables and batteries. I mean, that's a totally different time. And so to the extent that we understand, forget about climate change, the cost of human life and illness from pollution, 8.7 million deaths every year. If you just forget about climate change and say, you know what, that's not acceptable, and clean energy, we don't have to wait for a miracle. We know that it's cheap. The market is completely different. The state of New York is now, they have a divestment of their state pension fund. It's now the economic smart move to get to a low carbon economy. So even if you weren't thinking about the risks of climate change, it's almost one of these no regrets why do we want to burn dirt, use dirty energy and cause air pollution and kill people, even if you ignore the climate change issue?
Thank you, Jonathan. Question from Madison Tom. If we all agree that climate change deserves to be addressed, where does the money come from, and what % should be public versus maybe incentivizing private investments? And I don't know who wants to start with that. John Nelson, you've talked a bit about incentives, and
yeah, I'll be glad to take an initial crack at that. So the way our economy is structured, we have a robust way of funding things that are in the public domain and a robust way of funding things that are in the private domain. In my opinion, there's enough money. It's just not incentivized correctly. It's because we've got 150 years of momentum behind us that has set these systems in place that Jonathan just talked about. And in human systems, it takes a while to bend them. Anybody who's worked at a university knows how long it takes institutionally to change a little bit direction at the institutional level. So I don't think this is so much about where does the money come from as it is about how we incentivize the pools of resources we have out there. The municipal bond market is huge, and the municipal bond issuers are becoming very aware of this, and there is not a lack of demand, of investors for municipal bond issues.
And Mike, if I can add a quick public health analogy, it was when we raised the price on tobacco, the price on cigarettes, that we really knocked down the rates of teen smoking. So just like tobacco, we need a price on carbon, but I don't think that's the only thing. I think absolutely we need some big investments, big incentives to steer the market, to give the signal. So I think we need both, and I agree with John Nelson.
I'll just add to that. I think customers play a part in this from a private sector perspective as well. The more and more customers demand, not just hope, but demand that businesses practice, environmentally safe practices, the more and more I think you'll see those businesses adopt those because they'll lose customers otherwise. And so I think customers play a big part in this as well.
And Ben, this is John. If I can just follow up on that. One thing I didn't say about the Ford project is that they're trying to recruit the highest human capital available. And they are competing with Google and Apple and the biotechnology companies. And they're in the middle of the Midwest. So they need to build a campus that responds to the expectations of the humans they want to hire from great places like Wisconsin. And they won't accept anything less.
Absolutely.
Professor Ackerman, do you think universities can change quickly? John Nelson said maybe they can't.
He was saying that. I was thinking of the COVID-19 and how it hit us and how we went from full operating campus to nearly everybody off campus within a couple of days. So when we have to act quickly, we can.
Well done. Well played.
Yeah.
Well,
and right
Jonathan.
now, I'll just say, since December, we now have the student organization, the faculty, and staff, all three have passed resolutions for divesting from fossil fuels. So there's definitely attitudes have shifted across campus. So there's real alignment. That's nice to see.
I'd highlight that from the private sector as well. If you'd asked me 2 years ago, could the place I work at completely work remote, within a week, I'd have said no way. But when there's a need, there's a way. And as COVID hit, in a very, very short period of time, we went from a small percentage of the workforce working, remote to the entire workforce working remote. And I think again, it's just an example of how when there's a will, there's a way. And if this is a problem we want to solve, I think we could do it quickly if we mobilized around it.
Yeah, it's interesting. I think going back to incentives, I think those were great points because I think it's too hard for most people to see in their everyday life how serious this problem might be 20 or 30 years from now. And there just isn't that same urgency the way it was when COVID hit and we turned on a dime. So we have to think about how to incentivize that behavior. And I think those were some great insights. And I think that kind of brings us to the end. I appreciate all of you staying on an extra 10 minutes. I know there's some audience questions that didn't get answered tonight. I'm going to try to make a few connections between people in the audience and our panelists because I think there's a little bit more fruitful dialogue that could go on. But I really want to thank all of you for taking time on a Tuesday night to do this. I know we had a lot of viewers tonight and really appreciate you sharing your expertise and insights on an important subject.
And thank you. We appreciate UW alumni and making this happen.
Yeah.
You bet.
Thank you.
Thanks, everybody.
Great. Well, thank you all for joining us tonight. Very interesting program. And I especially want to thank those viewers who've been with us. It's almost coming up on a year now that we've been doing these shows since the pandemic began. We'll be back again next Tuesday, March 16th. We plan to have a show on the future of money, hopefully with tips on how the UW Foundation, UW Madison can acquire more of it to invest in all the important work going on here. But actually, we'll talk a bit about cryptocurrencies and how the traditional government currencies might fare long-term against these new startups. So thanks for being with us. Look forward to seeing you again next week on Wisconsin.
You can try, but you'll never stop a badger. Because we badgers are born with curious minds and endless heart. When we see a curve in the road, we speed up. When there are mask shortages for first responders, we make our own supply chain. When there's a world on pause, we sharpen our claws. Through thunder, fire, and pandemics, we'll keep going. Because after all, you can't stop a badger.